So now the question is, what do we do with a problem where the object is hanging on the string? Okay, so if I've got, say, a 5 kilogram mass here, and I exert a force of 120 newtons, okay, is there an answer on there? Yeah, negative 770 is great. I love that. Okay. Why is the correct answer, if I've got a mass hanging on a string in Earth's gravitational field, why is the correct answer not 120 divided by 5? Yeah, there's a downward force, isn't there, right? So this 120 newtons of force, they could call it the tension in the string, is not the only force. And so really, these types of problems, and this is all there is today, right? These types of problems, all we have to do is add the notion that there's a force, weight is mg. There's a force of gravity acting down on these guys, right? So 5 times 9.8 is what? It's 49, right? Yeah. So all you do in these types of problems is you just remember to add that force. You have to calculate it yourself. It's always m times g, right? And it's always down. That's not so hard, is it? Right? Now we're all set. Now we are where we were, I believe, I don't know, a half hour ago when I was saying, oh, this exciting new problem where you've got more than one force. Well, this guy's positive, this guy's negative. When it's up and down, let's always make up positive, down, negative. Okay? And now we're set. We can say 120 minus 49 equals 5 times a, right? Okay. And then I think we can do that. 120 minus 49 is 71. Guys, can we be quiet, please? We can talk when we're whiteboarding. Let's not talk right now. Okay, so 71 equals 5a divided by 5, right? Divided by 5. You get 14.2. Okay, now, let me suggest a more pirate way of doing this, right? If we had divided 120 by 5, what would we get? It's 24 meters per second squared, right? Yeah? That's how fast it would have accelerated without gravity. How do you suppose 24 and 14.2 are related? Do you suppose this is just 9.8 less? Take away 9.8? It is, yeah, it's 14.2. That always works, right? So you could pretend like there's no gravity, figure out the acceleration, then take away 9.8. That also works, okay? So there we go. What if we have a problem like this where we've got this guy and it's accelerating, let's say it's accelerating down at 3.2 meters per second squared, and it's 60 kilograms of stuff, and there's a cable here, right? And you're an engineer, and when it's accelerating down at 3.2 meters per second squared, what is the tension in this cable? What's the upward force? Right? How do we solve that one? Well, that's an unknown force problem, yes? We, by the way, kind of know it's upward, don't we? Okay, but let's pretend we don't, right? So what do? What's our first step? Yeah, mass times, right? So 60, the downward force is 60 times 9.8. So that's our first step. 60 times is 588 newtons, right? Okay. This force, we're going to pretend that we don't know which way it is, even though we know it's up, right? So we go T minus 588. Please stop, guys. I'll move you. Promise I will. Okay. So this guy, why did I say this guy was negative? Because it's always negative. The weight is always there. It's always negative. There it is, right? That equals 60 times. And then we got to be careful here. I need to borrow some room from that other part there. Look at that. Negative 3.2. There we go. Why was the 3.2 negative? Because I said it's accelerating down. Were it accelerating up, it would be positive, but because it's accelerating down, it's negative, right? So these are really pretty tricky. We've got to think about it. It's not just plug and chug. You got to think about the physical situation and decide, right? So we decided here, we decided there. It wasn't a big decision, but there it was, right? Okay. What that's going to do, by the way, is it's going to make, if you look at this, the tension is going to be 588 minus 60 times 3.2, right? That's what it ends up being. So it's this thing times this is actually taken away from the weight. There's less tension in that cable when it's accelerating down than if it's not accelerating at all. That makes sense, though, doesn't it? If it's accelerating down, it's less tension than it would be if it were just sitting still. Yeah? What about accelerating up? It's going to be more tension than if it were just sitting still or not accelerating, right? So we can do this. 588 minus 60 times. This ends up being 396 newtons. Right, so this is just two of the same problems, only they're up and down. The downward force is just always m times g. Yeah? Does that make sense? Should we try that? You guys can try, yeah. Yay, example, look at that. Woo, woo. Free body diagram does not mean you get a free body. All right. All right, find the acceleration. Here we go.